Hello, grade 12s, and welcome to Maths and Science 8. In this video, I am bringing you question 9 from the EC June 2022 Mathematics Paper 1 exam. Question 9 is a question about the applications of differential calculus, specifically in optimization problems. So let us dive straight into it. In the figure below, triangle ABE has a base of x meters. Okay, so I think this is worth noting. So here is triangle ABE and our base is clearly BE because we can see the perpendicular height. So this perpendicular base is x meters. That's what the statement is telling us. And then the next part of the statement says the base and the perpendicular height of the triangle add up to 10 meters. Okay, so let's take note of that as well. So this one is telling us that the base, which we now know that it's x meters, if you add it to the perpendicular height of the triangle, you will get 10 meters. And then the last part of the statement says the triangle is mounted on a rectangle BCDE, which has a perimeter of 32 meters. Well, I think that sounds very important as well. So we are being told that the perimeter of the rectangle BCDE equals to 32 meters. Now, let us go straight into the first question. 9.1. Show that the area of the figure ABCDE is equal to this expression, meters squared. Okay, very interesting. So we can obviously see that this figure is formed by two basic shapes, a triangle as well as a rectangle, meaning that to answer 9.1, we can simply say that the area of ABCDE will be equal to the area of triangle ABE plus the area of the rectangle BCDE. And obviously, we know that the area of a triangle is half base multiplied by height. And we can see in this case that our base is x and our height is h. So we'll have half x multiplied by h. Okay? And then for the area of the rectangle BCDE, we do have the length of the side BE. It's x, meaning that the opposite side CD is also x meters. However, at this point, we do not know the lengths for ED and BC. So we can just call that y for our convenience. And then going back to our expression, we know that the area for a rectangle is length multiplied by width. So we can now just simply say that this will be x multiplied by y. So clearly, in order for us to get this expression to be the same as the one that we are trying to prove, we need to get rid of h and y, because here we can see that the only variable is x. So how are we going to achieve that? We are obviously going to make use of the extra information that we were given from the statement of this question. Firstly, we know that x plus h is equal to 10, which is going to make it very easy for us to work out what h is equal to in terms of x. So based on this, we can say x plus h equals to 10, which means that h equals to 10 minus x. All right, so I'll just call this equation 1. And then we need to do the same thing, but now for y. For this one, we are clearly going to have to use the information that they gave us about the perimeter of the rectangle. So we know that the perimeter of BCDE will be equal to the sum of the lengths of all the sides, meaning that this is simply going to be equal to 2x plus 2y, because obviously in a rectangle the opposite sides are equal, as we had already noted that on the figure. But now remember that the perimeter is itself equal to 32. So we have this equation 32 equals to 2x plus 2y. And our job here is to work out what y is equal to in terms of x. So we need to transpose 2x into the left-hand side, and then we need to divide by 2 on both sides of the equation so that we get the value of y. So this simply means that y equals to 32 over 2, which is 16, minus 2x over 2, which is x. And we will just call this equation number 2. And now, obviously, our next step is to simply substitute in equation 1 and equation 2 into our current expression for the area for ABCDE. So if we do that, we will get that the area of ABCDE now equals to half x into h, which is equal to 10 minus x, plus x multiplied by y, which is equal to 16 minus x. And then we just now need to simplify this. So this will be half x multiplied by 10, so that will be 5x, and then half x multiplied by negative x, and that one will be negative half x squared. And then we have x into 16, which is 16x, x into negative x, which is negative x squared. And then obviously the next thing is to add up all the like terms. So we have negative half x squared minus x squared. So that will be negative 3 over 2 x squared. And then we have 5x plus 16x, which is obviously equal to 21x. So just like that, we have exactly shown that the area for ABCDE equals to negative 3 over 2x squared plus 21x meters squared. Now let's move on to 9.2. Determine the value of x for which ABCDE has a maximum area. Well, I'm pretty sure that you know the drill. Once you've got an algebraic equation for the scenario and they are asking you to determine a maximum or a minimum. So here we have an equation for the area of this figure in terms of x, which is 3 over 2 x squared plus 21x. And now to determine the maximum of this area, the very first thing is to work out the first derivative of this equation. So that will be negative 3 over 2 multiplied by 2, which will be negative 3. And then we'll have x into 2 minus 1, which is just x. And then this will just be plus 21. And then the next step is to set this derivative to 0 and then solve for x. So we can just transpose negative 3x into the left hand side to get positive 3x equals to 21. We divide by by 3 on both sides, and then we'll get x equals to 7. And now let me just explain why does this give us the value of x for which the area for ABCD is a maximum. Well, if we are looking into this expression or equation for the area of this figure, you will actually see that this equation here that it has is a quadratic equation. It's just simply a quadratic equation. And you can also see that the value of a is negative. Now, remember that for a quadratic equation, whenever the value for a is negative, it means that the shape for your quadratic function or parabola will be a frown, meaning that it will be concave down like this. And so if this graph here is the graph for the area of this figure, we see that the area of this figure would be a maximum at the turning point of this parabola. So whatever the value of x is at that turning point, that is the x value which corresponds to the maximum area for ABCDE. And so using differential calculus, how do we determine the turning point? We can use the first derivative because we know that at the turning point, the derivative of a parabola is equal to 0, which is simply because the gradient at the turning point is 0. So that is exactly why this works, which then brings us to the last part of question 9, which is 9.3, which says, hence, determine the maximum area of ABCDE. And so very straightforward because we already know that the maximum area is at x equals to 7, and therefore it means that the maximum area will be equal to this expression when x is equal to 7. So we simply need to substitute in 7 into that equation. So we'll have negative 3 over 2 into 7 squared plus 21 into 7, because that is our equation for the area of this figure. Right now we know that it would be a maximum at x is equal to 7. And so we just need to use a calculator. And if you do that, you are gonna get 147 over 2 as a decimal, that is equal to 73.5. So this is area. I would then just give it the units meters squared to be consistent with this question. So this is how you can do this question and any other question similar to this one. I hope that you have found this video very helpful. Please do me a favor by liking this video and sharing it with your classmates. And if you haven't subscribed already, please make sure that you subscribe. Otherwise, I hope to see you on another one. Good luck.